Greetings all, and we are required to find the derivative, the first derivative of the following functions. And the first function is given as y equals x raised to the power 3x minus e raised to the power x. And the second function is given as y equals ln of x raised to the power 3x. And the last function is given as y equals to bracket open ln x all raised to the power 3x. You see, so we are given these three functions and we are required to find the first derivative of each of the following functions. We start with the first one. Solution. So we take the first one, A. We are given y equals x raised to the power 3x minus e raised to the power x. So in this case, we are required to find the derivative, the first derivative dy dx. So since we are required to find the first derivative in this case, so the first point we are going to do, we take ln on both sides or we take log on both sides. So we introduce ln on both sides. Let's say introduce ln or log on both sides. So this is going to be ln y. We introduce ln to the right value again, ln of x to the power 3x minus e raised to the power x. This is the first step. So after having this first step, this value becomes power. So because this is a power, so we have to move it to the coefficient of this ln. So we still have ln y equals 3x minus e raised to the power x, and we have this logarithm ln x. So this power, this 3x minus e raised to the power ln x, 3x e raised to the power x, will move to the coefficient of this ln as it is written here, and we have ln x, and here we maintain, the left hand side we maintain ln y equals to 3x minus e raised to the power x ln x. This is the first step. And the second step, we differentiate because we are required to find the first function. So if we differentiate on both sides, we differentiate ln y and as well as we differentiate the right hand side terms given. So if we differentiate ln y, the differential of this ln y is going to be, let's just divide it. The differential of this ln y is going to be 1 upon y dy all over dx equals to, here we have two terms, so we have the bracket and we have ln x. So we use the product function, we can differentiate it one after the other. We can keep this bracket constant, we differentiate ln x first, we have a result, or we differentiate ln x or we differentiate ln x from there, we'll keep the bracket constant, or we'll keep ln x constant, we'll differentiate the bracket, either of the two ways. So let's say we keep the bracket constant, we'll differentiate ln x. So if the bracket is kept constant, 3x minus e raised to the power x. So if we differentiate ln x, always we differentiate the function given. The function here is x, so differentiate x is 1, and we rewrite the function x, which is 1 upon x, plus we keep this bracket constant, differentiate ln x. Now we are going to keep ln x constant and differentiate the bracket. So if we do that, so this is going to be 3x minus e raised to the power x, and we differentiate ln x into 1 upon x plus, now we keep ln x constant. If we keep ln x constant, we differentiate the bracket. If we differentiate 3x is 3, and if we differentiate this exponential function, e raised to the power x will still be the same value. So this will be 3 minus e raised to the power x. So this is it. So we simplified, we rewrite 1 upon dy dx equals, we maintain this is same as 3x minus 3 power x divided by x, plus this will still be ln x into 3 minus e raised to the power x. This is it. So this y, we can remove it, we multiply it throughout because it's fraction. So dy all over dx will be y multiplied by all of these terms, 3x minus e raised to the power x divided by x, plus this is ln x into 3 minus e raised to the power x. You see, this is it. But what is y? And we have the value of y to be this. So we plug the value of y. So in the final form, this will be x raised to the power 3x minus e raised to the power x into 3x minus e raised to the power x all over x plus ln x into 3 minus e raised to the power x. So this is the final result for the first function. This is the final result for the first function. So having this, we consider the second problem given. And the second problem again, we are given y equals to ln x raised to power 3x. We take the b case. If we consider the b case, we are given y equals ln of x raised to power 3x, bracket. Yeah, this is it. So this again is also similar to the first one, but in this case, we have a power directly here. This power, we can just move it to the coefficient of this ln. So it's going to be y equal to 3x ln x. This is how it looks like. Yeah, because this is the power, so we'll move it to the coefficient of this ln, and we have this. So what will be the next point? We'll differentiate y with respect to x. We'll differentiate this y, and as well as differentiate the two terms on the right-hand side, which is the product. So if we differentiate y with respect to x, we're going to give us the first derivative, dy dx, equals to, yeah, let's say we keep 3 constants, and we have the two terms, x and ln x. Let's say we keep x constant, if we differentiate ln x is 1 upon x, plus since we try to keep x constant, we differentiate ln x 1 upon x. Now we are going to keep ln x constant times we differentiate x, which is 1. So this is the formal result. So if we rewrite it now, dy all over dx equals to 3 into, what will be the value? Dy all over dx. Now we have dy all over dx equals to, we have the result. We have the result of that. Dy all over dx, we maintain our 3 into x, will cancel x, this will just be 1 plus ln x times 1, this will be ln x. So therefore the final result of this is going to be 3 into 1 plus ln x. So this is the final result for the second function given. So this derivative dy all over dx equals to 3 into 1 plus ln x. This is what we have. And we shift to the last value. And the last value is somehow simple and straightforward, but it involves certain stages we need to consider seriously. So if we take the last problem, y equals ln x raised to power 3x. Let's consider this. So if we consider the last one, we say c is given as y equals ln x raised to power 3x. So in this case, this one is different from the first one. We are in here, this second one, where you can just move the power, it's automatically. But this ln x is raised to the power 3x. It's not like this function is raised to power 3x. For the b part, the function x is raised to power 3x. But here, the whole of the ln function in x is raised to power 3x. You see, so we need to be careful on how to resolve this. So the easiest way, we take ln on both sides. We take ln on both sides. So introduce ln, or you can say log on both sides. On both sides. So if we introduce ln or log on both sides, so we have the function to be. So if we do ln, this is going to be ln. We take ln for the left, which is ln y. We take again ln for the right again, which is ln x all raised to power 3x. You see? So the moment you take ln, definitely this value has become a power, so we can easily move it. So if we do ln y equals to 3x, ln into ln x. So this is what we have. You see? So this again has given us two product values. We have x as a product. We also have ln into ln of x as also another product. So we differentiate them step by step. So differentiate ln y, as we have been doing, is 1 upon y dy all over dx. Let's factorize 3. So we have the terms, we have x as a term, we also have ln of this ln as a term. So if we keep this ln and ln x as a term, let's say keep it ln and ln x as a term, and if we differentiate x is 1 plus Now, since we keep this constant, differentiate x, now we are going to keep x constant and we differentiate this ln of the next function. So if we do that, if we differentiate this is the function, ln is the value given and the function inside is this. So when you differentiate the function. So differentiate x is 1 all over, which is ln x, times, now if we differentiate this ln x, is going to give us 1 all over x. This is what we have. So this 1 upon y, we can rewrite this 1 upon y dy dx equals to 3 into ln x plus, because one time this is just this, and here x will cancel x, is just going to be 1 all over x. This is what we have. So the final answer, this y we multiply it to that value, so it's going to be dy all over dx is going to be 3y into ln x plus 1 all over ln x. This is what we have. But in this case, the final result that is going to be 3. What is y? And we have y to be this value. So we slot it into ln x all raised to the power 3x, and we have the value given ln x plus 1 upon ln x. So this is the final result given. Thank you. Stay blessed. Please subscribe, like, and leave a comment. Thank you.